Well, hello again and welcome to the VK6CS Fun with Amateur Radio channel. Is it possible to have more fun with amateur radio? I hear you cry. Well, probably, to be honest. But for now, here's the switching module that I made for my power amp. And what I wanted to do was find out whether the output relay makes before the input relay makes. Now, it doesn't have to be by much, millisecond or a couple of milliseconds or so would be spot on, because the amplifier shouldn't be driven with power, so that it's driven with RF so that it produces power with no load on it, because if the amplifier is producing power, there's no load connected to there, the voltage across the valve can get quite high enough for things to flash over and break down. So it's important that the load is connected to the amplifier before it starts producing power. So we want this one to come on, and then just afterwards we want this one to come on. So the load is connected and the drive is applied. Now what I've done is I've just got a couple of pull-up resistors here, pulling up to 12 volts. And I've got this this gizmo here configured to show the time delay between the falling edge of channel 1 to the falling edge of channel 2. So the output is connected to channel 1 and the input is connected to channel 2. So when I activate the PTT keying line, the input and output relays activate, and I'll see how long it takes for, or see if there's a time difference between the output and the input. Now I want this one to come on first and this one to come on slightly afterwards. And if we get a positive delay, that's what we've got. If we've got a negative delay, we've got a problem, or I've got a problem, and I'll have to just put a little bit of a delay in there somewhere. Now I've cheated, of course, and I have done this before I fired the camera up, so I know that it works fine. But I'll pretend to be surprised, okay? Right, so there we go. So if you just look at that, look here, this is where the delay will be indicated. And I'm holding the camera, so apologies for that. So 1.1 milliseconds, 1.1. Actually, I can't. I'm looking at the viewfinder on the camera here. I can't actually see. Let's just look around the camera. 1.2 milliseconds. 1.6. 1.2. 1.3. 1.095. Ooh, that's getting a bit close. 2.097. 1.5. That's what's happening to the. You can see the DC voltages are being pulled down there together as I'm doing that. 1.3, 1.29, 1.7, 1.2, 1.9 was that? 1.1, 1.1, 1.3, 1.2, 1.2. Now I can hear you saying this is what we call fun, so yes, you're absolutely spot on. And I can tell you're riveted to the screen, but I've got bored, so I'm not going to keep doing that. Suffice to say that I have done that quite a number of times, and on every occasion the output relay makes at least a millisecond before the input one does. So there's always going to be a load on the amplifier. Remember, a millisecond in electronics is an age. So this one makes, millisecond later that one makes. So load is applied, drive is applied, and that's exactly what we want. So there we go. Hope you found that interesting. That means, of course, that I can draw a line under that now. That can be installed in the amplifier without modification. If I'd needed to put a bit of a delay in the loop, I'd have put another little relay in there, just so that when this one activates, it actually activates the other little relay, which activates that relay, if you see what I mean. So it would just put a couple of millisecond or so delay in there to slow the drive down, so that the amplifier would always have a load before the RF drive was applied. Don't need to do that. because, as you just saw on each and every occasion, the output relay makes first. Alright, well I hope you found that interesting, and as always, thanks for watching. I'll catch you next time.